Hide the planet! Hide the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Dude, where's my avatar? Here we go. Okay, hello, nice to see you here. My name's the Shy Hat, and we're doing HackerFrogs co-working today. We're going to be doing a co-working and Hangout stream, as indicated over here by the schedule. Today's co-working Tuesday, and it's currently 8 p.m. where I am. I don't know what time it is where you are, but we're going to be working for about 3 hours, and we're going to be getting some work done. I'm going to be learning C programming, and if you want to hang out, if you want to do some co-working yourself, you are very welcome to do so. So let's go ahead and put a little bit of a timer on the topic. The topic is co-working and chat. You're free to chat about anything you want to, about cybersecurity, about tech, and I will be here and I'll be studying, because it's important to keep on studying and keep on self-improving. So let's see. While we do our course, let me put on a little bit of background music. And it's going to be a little bit easier to focus with some music. Okay, so let's go ahead and get started. Where were we? Here. So we're currently doing a course on C programming. If you're interested in taking this course yourself, it's free, and you can find it over here. Anyways, we're currently doing a C course. We're talking about conditionals, we're talking about loops, we're talking about all sorts of fun stuff. And Sir's Cats, hello, nice to see you here. How are you doing? And welcome to the YouTube chat. So computers and their logic, all right. So we can notice that conditions we've used so far have been very simple, not to say quite primitive. The conditions we use in real life are much more complex. Let's take a look at the sentence. If we have some free time and the weather is good, we'll go for a walk. We've used the conjunction and, which means we're going for a walk, which means that going for a walk depends on the simultaneous fulfillment of two conditions. In the language of logic, the connection of conditions is called a conjunction. So now, another example. If you're in the mall, or if I am in the mall, one of us will buy a gift for Mom, okay? Okay, I am Black Shell if you remember me. Sir Cats, Black Shell. The name sounds kind of familiar, but can you refresh my memory? What were you talking about last time? The appearance of the word "or" means that the purchase depends on at least one of these conditions. In logic terms, this is called a disjunction, so conjunction and disjunction. So therefore, the C language must have operators to build conjunctions and disjunctions. Without them, the expressive power of the language would be substantially weakened. We call these logical operators. We've got and, we've got not, and we've got or. And, not, and or. Pride, and, prejudice. The logical conjunction operator in the C language is called a digraph. So a double ampersand, ampersand, ampersand. So this is a binary operator with the lower priority than the comparison operators. It allows us to code complex conditions without the use of parentheses like this one. So counter greater than 0 and value equals 100. So the result provided by the AND operator, the AND operator, can be determined by the on the basis of the truth table. If we consider the conjunction of left and right, the set of possible values of arguments and corresponding values of the conjunction looks as follows. Sorry, what we got here? Okay, you see that website EW Skills. The website EW Skills. You know what? That sounds familiar. Were you suggesting some sort of education website last time? Okay, so if left is false and right is false, then left and right is false. If only left is false or if only right is false, this is also false. It's only when they're both true that the overall statement equates to true. Okay, looks like I got logged out. Looks like the session cookies are not very long lasting over here. Okay, let's continue. So computers and their logic, next. Okay, to be or not to be. The disjunction operator is the digraph bar. So bar or pipe. It's a binary operator with the lower priority than and, just like the plus compared to the multiply. Its truth table looks as follows. Okay, breaking out the logic tables, I see. Yeah, we're trying to. Okay, Sircat says, digital and embedded C is free and very, very good. EW skills. Let me search for it in another window. EW skills. Is it called EW Skills Academy? New Skills Academy. Okay, always check the precedence table for any language you use. It's not universally the same. Yeah, it can really result in some gotchas if you're not paying attention. Okay, in addition, there's another operator that can be used to construct conditions. It's a unary operator performing a logical negation. The operation is simple. Its operation is simple. It turns true into false and false into true. This operator is written with a single character, so the bang exclamation point, and its priority is very high, the same as the increment and decrement operators. So the truth table is truly simple. So arg false true, not arg is true false. So basically the opposite. Some logical expressions. Note that the following conditions are equivalent, respectively. So variable greater than 0, not variable less than or equal to 0, or variable not equal to 0, and not variable equal to 0. Okay, so Randolph says you could always use parentheses and make it explicit in almost every language. Yeah, I think that sounds like a neat trick, but I guess we have to understand how the language does it in the first place, and then figure it out when bugs start to appear. You may remember De Morgan's laws from school. They say that the negation of a conjunction is the disjunction of the negations. Okay. The negation of a disjunction is the conjunction of the negations. So let's try to write the same thing using C language. So not P and Q is equal to not P or not Q. Not P or not Q. Oh, this is interesting. So not and is the same as not one or not the other. And let's see, not P or Q is the equivalent to not P and not Q. Okay, also in RPN notation, for example, there are no parentheses. Oh. I guess it really depends on what kind of system you're working with. Note how the parentheses have been used to code the expressions. We should add that none of the previous two argument operators can be used in the abbreviated form known as op equals. Op equals. I don't think I've seen this one before. This exception is worth remembering. How to deal with single bits. Logical operators take their arguments as a whole, regardless of how many bits they contain. The operators are aware only of the value 0 when all the bits are reset, which means false, not 0 when at least one bit is set. This means true. The result of their operations is one of the values, either 0 or 1. This means that the following snippet, integer ij, j is equal to not I. We will assign a value of 1 to the j variable if I is not 0, otherwise it will be 0. We will assign the value of 1 to the j variable if I is not 0, otherwise it will be 0. Nullsec says, trying to get Tyler to raid. Wow. I mean, Tyler doesn't need to raid into the channel that often, but thank you very much, Nullsec. Hope you guys are having fun over at Tyler's channel. So, however, there are 4 operators that allow you to manipulate single bits of data. We call them bitwise operators. So they cover all the operations we've mentioned before in the logical context, and one additional operator. This is the XOR, exclusive OR, and is denoted by the caret. Here are all of them. So the AND is the bitwise conjunction, the bar is the bitwise disjunction, the tilde is the bitwise negation, and the caret is the bitwise exclusive OR. Okay, let's make it easier. AND requires exactly 2 1s to provide 1 as the result. OR requires at least 1 to provide 1 as the result. So XOR requires only 1 to provide 1 as the result, and tilde is 1 argument and requires 0 to provide 1 as the result. Okay. Yeah, I took a look at the New Skills Academy, and are all of these courses free, or are some of them paid? Most of the time I deal with courses that either have like a lot of freemium content or stuff that is completely free. Okay, but take note, arguments of these operators must be integers. Integers as well as long, short, and characters. We must not use floats here. So the difference in the operation of the logical and bit operators is important. And logical operators do not penetrate into bit levels of its argument. They're only interested in the final integer value. Okay? Not Academy EW Skills is free. EW Skills. Okay, it's not New Skills Academy, it's a different one. You're talking about EW skills.com. So I see a link right here. You talking about this one? Okay, so this is a different thing, yeah, for sure, for sure. I'll have to take a look when I've got some free time. Thank you very much, Sir Cats. Bitwise operators are stricter. They deal with every bit separately. If we assume that the integer variable occupies 32 bits, you can imagine the bitwise operation as a 32-fold evaluation of the logical operator for each pair of bits of the arguments. Obviously, the analogy is somewhat imperfect, as in the real world, these 32 operations are performed at the same time. Okay, free everything. That does sound very appealing, yeah. So left, right, left and right, left, right, left or right, left, XOR right. Left. You know, this is I'm sure I'll figure it out when the examples are a little bit more concrete. Okay, let's take a look at the example of the difference in operation between logical and bit operations. Let's assume that the following declaration has been performed. So integer I equals 15 and j equals 22. If we assume that the integers are stored with 32 bits, the bitwise image of the two variables will be as follows. So I is going to be this binary number, which means 15, and j is this binary number, which means 22. Red Sly Fox says, late stream. Yeah. Ghost HX, hello, nice to see you here. And I have a question for you. Yeah, go ahead and ask your question, Ghost HX. So the declaration is given. Integer log equals I and j. I and j. So this is where the bitwise operation is going to happen. So it's going to return like a 1 if both of these bits in the same position are 1, and 0 otherwise. We're dealing with a logical conjunction. Let's trace the course of the calculations. Both variables I and j are not zeros, so will be deemed to represent true. If we look at the truth table for the and operator, we can see that the result will be true and that it's an integer equal to 1. This means that the bitwise image of the log variable is as follows. Incoming Tyler raid. Okay, and flashbacks to submitting. Yeah, I guess you would see this kind of stuff when you're doing computer networking stuff. Okay, so log is equal to 1. Integer log equals I and j. So this equates to true. I guess it equates to true because these are none of these are absolute 0. Okay, Ghost HX asks, do you think it would be hard to hack a service provider if you get someone's GTS7 IMSI? Well, I mean, I've never really hacked anybody's... You're talking about internet service providers or something else? Sir Cat says, is this the website where you learn? There's no actual applications of things you learn? No, there are exercises here. If you take a look at the website, edube.org, there's actually a lot of good interactive courses. So especially Python, they've got like a couple of really good introduction courses to Python. They also have courses on JavaScript, on C++, and on C. But I think it is important to teach people about the theory behind the languages, as well as coding challenges. So now the bitwise operation, here it is. Integer bit equals integer bit. Okay, so integer bit equals I and j. And HackSmarter just rated the channel with 20 viewers. Hello, HackSmarter viewers. And hello, HackSmarter. Let's give HackSmarter a shout out. there you go. HackSmarter does cybersecurity content on Twitch and on YouTube. And if you're interested in learning about practical pen testing skills, go ahead and check out his channel, yeah. Thank you very much for following on Twitch. Australian Pop EXD, thank you. My name's The Shy Hat. I do cybersecurity content on Twitch and YouTube, and right now we're doing a stream on it's a co-working stream. So if you're interested in getting some work done and also maybe learning about the C programming language, this is what I'm going to be doing while the co-working session is going on. Pope, it's Pope. Australian Pope XD, is that it? Thank you. Thanks for following 086 Legend, thank you. But yeah, we're just learning some nuts and bolts about C right now, because we need to learn this to get better at binary exploitation and reverse engineering. So the AND operator will operate on each pair of corresponding bits separately, producing the values of the relevant bits of the result. Therefore, the results will be as follows. So bit is going to be this value here. So these bits correspond to the integer value of 6. And Taco Mando, that's a great name. Nice to see you here. What were you all covering on your the HackSmarter stream? Were you doing more Active Directory stuff, or was it something else? So let's try the negations operator now. First, the logical one. So integer log neg equals not I. The log neg variable will be set to 0, so its image will consist of zeros only. Oh, it's AWS hacking. Okay. Released a free lab called the Second. That's awesome. I need to do more Active Directory hacking exercises. I might be trying that out myself. But thank you for letting me know about that, HackSmarter. And thank you very much for the follow on Twitch, TacCommando. Thank you. Okay, so integer bit neg equals not I. It may be somewhat surprising that the bit neg variable value is -16. -16. Strange? Not at all. If you're surprised, we hope it'll be an incentive for you to immerse yourself in the secrets of the binary numeral system and the rules governing 2's complement numbers. So log neg is this value right here, and bit neg is this one right here. So that's interesting. Why does this actually come out to a negative number? Oh, HackSmarter was having some voice issues. I'm sorry to hear that. Okay, each of the previous 2 argument operators can be used in their abbreviated forms. The following notations are equivalent, respectively. So x and y, x and equals y, x and equals y. I've never seen this notation before. I've never seen these notations, but it's interesting that they're valid. Bit of a sore throat, he'll be okay. Oh, I hope so. Bitwise operators. So we'll now show you what bitwise operators are good for. Imagine that you're a developer who has to write an important piece of an operating system. You've been told that you have to use a variable declared in the following way. So integer flag register. Okay, the variable stores information about various aspects of the system operation. Each bit of the variable stores one yes or no value. You've also been told that only one of these bits is yours. Bit number 3. Remember that the bits are numbered from 0, and bit number 0 is the lowest, while the highest is 32. Okay, so this is bit 0, this is bit 1, this is bit 2, and this is bit 3. And this is bit 31, because we start counting from 0, and we count from right to left, which is a bit confusing. Why right to left? why right to left? That's a good reason. I mean, that's a good question, right? Because when we're talking about like 32-bit numbers, well, let's just do something a bit simpler, right? So if we're talking about 8-bit numbers, let's make this nice and big. So it's 1, 2, 3, 4, 5, 6, 7, 8. So if we're using like 8-bit numbers to represent the number 1, we basically read in the positions of the bits from right to left. So this is the 0th bit, 1st bit, 2nd bit, whoops, 2nd bit, 3rd bit, up until the 7th bit here. So we start at 0 bit and then to bit number 7. Anarchist says, in order of significance, bit 0 is the least significant byte, which is the smallest. Yeah, so I mean, if we have a 1 in this position in an 8-bit number, it makes more of a difference because this represents a really big number, as opposed to if this is activated, it really doesn't affect the number as much. Okay, Nullsec says, if it's signed, is that bit on the right or left? If it's signed, is it on the right or left? I guess they'll tell us in just a little bit. This is something that I need to figure out myself. Okay, you may face the following tasks. Check the state of your bit. You want to find out the value of your bit. Comparing the whole variable to 0 will not do anything, because the remaining bits can have completely unpredictable values, but we can use the following conjunction property. So x and 1 equals x, and x and 0 equals 0. X and 1 equals x. X and 0 equals 0. So if we apply the AND operator to the flag register variable along with the following bit image, so the bit image is everything but our bit, which is bit number 3, so it's 0, 1, 2, 3, set to 0 except for ours, which is 1. What's the site name? So this site is edub.org, and the course is called C Essentials Part 1 over here. Cypher says Little Endian and Big Endian, I think, are what refer to which way you read them. Yeah, so Little Endian is read from right to left, and Big Endian is left to right. Okay, Sir Cat says it seems very complicated when you start with programming and not hardware. When you start with programming and not hardware. I mean, I'd like to eventually get to hardware, but I think I should start with software first. Okay, notice the 1 at your bit's position. We obtain one of the following bit strings as the result. So if your bit was set to 1, then it would give us 0. So this, you get the same result if the bit was set to 1, and you get 0 if your bit was reset to 0. A sequence of zeros and ones, whose task is to grab the value or to change the selected bit, is called a bit mask. Let's try to build a bit mask to detect the state of your bit. It should point to the 3rd bit. That bit has the weight of 2 to the power of 3 equals 8. 2 to the power of 3 equals 8. A suitable mask can be created with the following declaration. Nedmac says, Endianness is the dumbest thing. Endianness is the dumbest thing ever. People just want to be different for essentially no reason. I mean, I'm sure there's a good reason for why certain systems are big endian and certain systems are little endian. Endianness, SysOS Master says, Endianness is mainly about the order of the multi-byte values. Okay, so the mask equals 8. So we can also make a sequence of instructions depending on the state of your bit. Here it is. So if flag register and the mask, my bit is set. Else, my bit is set. Else, my bit is reset. Okay, so the bit has the weight of 2 to the power of 3. So 2 to the power of 3 is 8. So I guess when we're talking about a 32-bit number... Ah, okay, so I think I understand. So when we're talking about a 32-bit number here, this represents 0 or 1, this represents 2, this represents 4, and this represents 8. So that's why the mask is 8 in this case. Okay. So reset your bit. You assign a 0 to the bit, while all the other bits must remain unchanged. We'll use the same property of the conjunction as before, but we'll use a slightly different mask, exactly as below. So this time our mask is all 1s, except for our bit, which is 0. Note that the mask was created as a result of the negation of all the bits of the mask variable. Resetting the bit is simple and looks like this. Choose the one you like more. So flag register equals flag register and not the mask. Or flag register and equals not the mask. Okay, nullsec says, I think the Soviets had a trinary system. Are you talking about binary versus... Are you talking about why we use binary computing systems? I think it's a very interesting... It's a very interesting concept, right? Our computers are binary, so they read in only binary digits. So basically, they're pulses of electricity, which represent zeros or ones. Okay, so select your bit. You assign a 1 to your bit while all the remaining bits must remain unchanged. We'll use the following disjunction property. So x or 1 equals 1, x or 0 equals x. So we're ready to set your bit with one of the following instructions. So flag register equals flag register or the mask. Flag register or equals the mask. Negate your bit. You replace a 1 with a 0 and a 0 with a 1. We'll use an interesting property of the XOR operator. So x XOR 1 equals not x. X XOR 0 equals x. Okay, nullsec says, I loved learning about that hardware. Which hardware are you talking about? Setun or something? Is that what you're talking about? And negate your bit with the following instructions. Flag register equals flag register XOR the mask, or flag register XOR equals the mask. Okay, bit shifting. The C language offers yet another operation related to single bits, shifting. This is applied only to integer values, and you mustn't use floats as arguments for it. You use this operation very often, quite unconsciously. How do we multiply any number by 10? Let's take a look. So 1, 2, 3, 4, 5 times 10 equals 1, 2, 3, 4, 5 plus another 0. As you can see, multiplying by 10 is in fact a shift of all the digits to the left and filling the resulting gap with 0. Division by 10, let's take a look. So 1, 2, 3, 4, 1, 2, 3, 4, 0 divided by 10 equals 1, 2, 3, 4. So dividing by 10 is nothing more than shifting the digits to the right. So the same kind of operation is performed by the computer, but with one difference. As 2 is the base for binary numbers, not 10, shifting a value 1 bit to the left corresponding to multiplying it by 2, respectively. Shifting 1 bit to the right is like dividing by 2, notice that the rightmost bit is lost. Bit shifting can be logical. If all the bits of the variable are shifted, shifting takes place when you apply it to unsigned integers. Unsigned integers, so they can't be negative numbers. Okay, arithmetic. If the shift omits the sign bit in 2's complement notation, the role of the sign bit is played by the highest bit of the variable. If it's equal to 1, the value is treated as a negative. The sign bit is played by the highest bit of the variable. So if it's equal to 1, then the value is treated as a negative. This means that arithmetic shift cannot change the sign of a shifted value. The shift operators in the C language are a pair of digraphs. So what is that? So it's double less than or double greater than. So value, what is this? So is this like left shift or which one is left shift? This is left shift, right? So this is left shift and this is right shift. So value left shift bits, value right shift bits. Okay, clearly suggesting in which direction the shift will act. The left argument of these operators is the integer value whose bits are shifted. The right argument determines the size of the shift. This shows that this operation is certainly not commutative. The priority of these operators is very high. You will see them in the updated table of priorities, which we'll show you at the end of the section. Okay? Let's assume the following declarations exist. So integer signed equals -8 var s. Integer signed equals -8 var s. Oh, okay. So the name of the variable here is signed and unsigned. So by default, variables are signed, but if you declare them as unsigned, so unsigned equals 6 var u. So I guess var u means unsigned, and s means signed. So take a look at these shifts. They're shown in the editor, okay? Both operators can be used in the shortcut form as below. So signed, bit shift right, bit shift right equals 1. So that's division by 2. And unsigned bit shift left equals 1, multiplication by 2. Okay, and here's an updated priority table containing all the operators included in this section. So there's a lot of symbols to take in here. Okay, I wonder what they want us to do in this section. I mean, we can play around with the code window a bit. Think of it as moving the decimal in the direction of the arrow. Remember, it's binary. So okay. So var s equals signed. Var s equals signed bit shift 1. Okay. I don't think we can do anything with this code because they weren't really declared in the code. Let's go ahead and do this. So we can go ahead and assign the variables up here. And I guess what we can do is we can just start playing around with this. So like we can printf var u. Maybe this is the unsigned the unsigned variable. This is going to be like a digit. We'll do like two printfs. And that's going to be unsigned. And this is the var u var. That's var u. Vars and var u. Playing with binary is really fun. Well, something we're studying. Let's see if this runs. What happened here? Oh, okay. I think there might be a problem because we don't have the right headers. What was it again? It was like include. stdio.h, like this. What did we agree? I don't think I agreed. No. It's something we do have to study, and like binary numbers are foundational because, you know, computers run on binary numbers. Hold on. Where'd I screw up? So printf, this is the unsigned variable. %d. Do I have a syntax error in here? Expected declaration specifiers. So include standard io.h. So this is number 19. Expected declaration specifiers or before printf. Declaration specifiers. Did you include standard io.h? Yeah, it's up here. Did I spell that incorrectly? Yeah, so I'm not too sure why the code isn't running. So unsigned and var u. So var u is here. Unsigned is here. What kind of data is var u? So var u is unsigned and then bit shifted to the left by 1. So it should be an integer. So I'm not too sure what's... oh, there's no main. Yeah, right. There's no main function. So we might want to put this on inside of, like, with int void main, and just put it between some of these, and then return 0. Okay, and we'll see if it works now. 2 or more data types and declaration specifiers and int point. Oh, okay. So it's int main void. Int main void, not int void main. Okay, let's try it again. Okay, so this is the unsigned variable 6. This is the var u variable, which is multiplied by 2, so now it works. Well, I'm glad we're able to debug that. So it didn't work because there was no main function. Okay, we can move on. Void or int, not both. Yeah, it's something I need to get used to. Okay, so level of difficulty easy. Familiarize a student with fixing errors in a program, integer numbers, printing on screen. Write a program that computes and prints whether or not a given year is a leap year. So a leap year is a year that is exactly, without a remainder, divisible by 4, except for years that are exactly divisible by 100. But these years are leap years if they are exactly divisible by 400. Use the modulo operator and some logic operators in your program to try to write only one condition. Of course, you can now use the else keyword. Your version of the program must print the same result as the expected output. Sample input, 2010. 2010 is not a leap year. 2015 is not a leap year. 2000 is a leap year. And 1900 is not a leap year. Okay. So I think we can get this done. So we just need to do like scan, well, we'll do like puts. Puts with a little message, input the year. Okay, and then we would do like scanf. Scanf that takes in an integer or like a digit, and we would assign that to year. I guess we need to declare the variables here as well. So integer year. Okay, and they want us to do the check. So if something if year modulo if year modulo 4 let's see. So year modulo 4, it's going to be checking if it's not 0. If year modulo 4, so I guess we're checking if it's not a leap year. Why year? Why year? Oh, sorry, it's supposed to be this one, right? To assign it to year. Pointer and hint. Pointer and hint. Yeah. Just need to get used to coding in C again. So if modulo year, Talk Commando has just subscribed with tier 1 on Twitch. Thank you very much, Talk Commando. And let's give you a special video redeem just for you. How about some Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Okay, and you forget next integer year. Oh, yeah. Thank you for reminding me about the semicolons. Okay, so if year modulo 4, so this is checking that it's not 0. If you're in modulo 4, or, sorry, it's going to be or year except for years that are exactly divisible by 100. So exactly divisible by 100, so it's going to be modulo 100. So we're checking that it's not. So maybe not year modulo 4, and or. So not year modulo 4 is checking for if it is evenly divisible, right? And year modulo 100 is checking that it's not double. Double will give you an error. Where's there a double parentheses? Are we not allowed to do multiple comparisons at the same time? I thought we were. Or year and not year modulo oh, I guess we need to check. So it's if year modulo 4 or year modulo 100 and year modulo 400. Okay, let's see. Where's the 400? Yeah. It only supports a single statement. If only supports a single statement. Really? I didn't know. I guess I need to find out. Use the modulo operator and some logical operators in your program to try to write only one condition. Only write one condition. So of course you can use the else keyword. So if, else, if. Okay, so I guess we can only do one comparison here. So if something, then do something. Else. Else like this. Okay, Anarchist says you can have multiple comparisons, but it has to be coded like if condition 1 and condition 2. Oh, really? Okay, so else, I mean, I guess the else statement here is just going to like print, or puts, right? Puts. And you're looking for, oh no, it's still printf. D is not a leap year. Okay, you can use nested ifs too. I'd prefer, well, I guess if it's absolutely required. Okay. So scanf if year. Alright, so Randolph says, no, sorry, Anarchist says you can have multiple comparisons, but it has to be like if condition 1 and condition 2. Okay, so it has to be like nested parentheses. The syntax is still wrong because your condition still isn't in parentheses. So it has to be something like this. Could also use a library, but that's not the task. No, I don't think so. Okay, so if year modulo 4, if year modulo 4 equals 0, it's like if where something is one of your conditions. So if year modulo 4 is 0 and, so you'd put it between some double parentheses like this. So we're checking that it's, what was that? Except for years that are exactly divisible by 100. So and year modulo 100 equals and not year modulo 100 equals 0, and year modulo 400 equals 0, then printf something something is a leap year. Okay, if you need to group, then yeah, add extra parentheses. So, I mean, I'm not sure if this is the way we want to write this code, but let's see if it works. Drum roll, please. Input the year. So, 4. 4 is not a leap year. 4 is not a leap year. Oh, okay. I see where my logic is failing here. So if year is divisible by 4 evenly, then we have to write. Okay, not year would be the negation of the year modulo 100. So I think we can grab this. We'll reset it, and we'll just do the test case. So 4 is a leap year, right? So this works. Else, so is there an else if in C? Is there an else if in C? Okay, you can use else if in C. Technically, C does not have a single else if keyword. It has the else keyword directed by a separate if statement. Okay, so sure. Okay, so else if year if the year is not so not year modulo 100 equals 0. I guess it works if the year modulo 100 is 0 and year modulo 400 then print it is a leap year. And then the final else printf is not a leap year. Okay, confirm test conditions. Yeah, well, I mean, let's see if I manage to write this correctly, of course. Alright, so reset this. Input the year. So 400? 400 is a leap year. Okay. And then we'll do 100? 100 is a leap year. 100 is a leap year. So we're not counting... Well, if we modulo it by 400, how about 19? Okay, let's try 1900. 1900 is a leap year, so this isn't quite working the way we want to. So else if not year, It's like not year modulo 100, very different. 2000? I think... So 2000 should be a leap year. The problem is that it's a bit screwed up. So year modulo 100 is 0, and year modulo 400 is 0. But these years are leap years if they're exactly divisible by 400. Show us the sample input. So the sample input is like 2010 is not a leap year. Well, I mean, we'll try running the program. So we'll try 2010. Oops. So it's not a leap year. 2015 is also not a leap year. Enclose year modulo 100 in parentheses and preface by not. Okay, so let's change this up. So else if not year Okay, and then we're looking for 2000 is a leap year, but 1900 is not a leap year. All right, run it. So we're looking for 2000 is a leap year, and then 1900. Ooh, 1900 was flagged as a leap year. So not year modulo 100 equals 0. So I think what we're looking for is maybe year modulo 100 is 0, and year modulo 400 is also 0. I guess we need to get rid of this parentheses. Okay, is the number not 45? 45? Okay, we'll run this again. Oh, what we got? So this is 12. Okay, we need to put our parentheses in here. Logic is exited before getting to the modulo 100. Yeah, okay. So you need to combine it all. Year modulo... so we're only looking for one comparison, right? Okay, let me copy paste your code. Just a sec. So we just need one. And we can get rid of the else if and just include the else. So if year modulo 4 is 0 and year modulo 100 is not 0, or year modulo 400 is 0, then printf this is a leap year. Okay, let's give it a try. So this is 1900 is not a leap year. Okay, so there's only one comparison here. So we're doing the OR operator. Year modulo 100 is not 0, or year modulo 400 is 0. Okay, so I think we've got the correct output here, so we can move on. Thanks for the assistance, guys. Okay, dealing with single bits and groups of bits. Oh, bitwise operations, fun. Taking input from the user and integer numbers, printing on screen. So a nibble is just a 4-bit aggregation. We can also call it a half byte. Sometimes we use the terms low nibble and high nibble to denote nibbles containing less significant bits, low nibble L, and more significant bits, high nibble H within a byte. Write a program that asks the user for one integer number smaller than 256 and prints both nibbles of the number. You don't have to verify the input. That's good. Your version of the program must print the same result as the expected output, so sample input 255, high nibble is 15, low nibble is 15. 63, high nibble is 3, low nibble is 15. Okay, so sometimes we use the terms low nibble and high nibble. Let's just write the first. Someone was really proud of getting it named that. The nibble and the byte. I guess so. So I guess what we need to do is we'll define our user input. We'll call this the 8-bit int. And this is going to be the an integer int, 8-bit int. That was serious scientists back in the 40s and 50s. Some registers use half bytes, and the extended register uses both the high and low bytes. Yeah, I think, I mean, we're talking about, like, x86 memory registers, right? Okay, so we'll do, like, puts. So, let's see. One integer number smaller than 256. So maybe enter a number between 0 and 255. And then scanf. Take this in as an integer and assign it to 8-bit int. So write a program that asks the user for one integer number smaller than 256 and prints both nibbles of the number. You don't have to verify the input. So 255, the high nibble is 15. The low nibble is 15. So the high nibble is 15, the low nibble is 15. So we're talking about like the hexadecimal digit, right? Because if we take a look at so this is more 8-bit numbers. So this is if the number is 255, we have to convert the number to an 8-bit hex digit. So in the case of 255, so 255 equals FF. Yeah, 4 bits. So the hex value. So this is the low nibble and this is the high nibble. So low nibble equals F and high nibble equals F. So what were the other examples? Hand so high. So as Bro, weird question. Maybe after doing this course, you can open source your learning, open source my learning on a repo. I'd look at it, but I assume the C++ course won't cover everything since C and C++ is huge. Yeah, I mean, it's pretty big. Nibble size is platform specific. It's not always 4 bits. Really? Could do a bit shift in either direction and read. Yeah, I do YouTube videos, and I've got a GitHub. So if you want to learn about how I do learning in general, I guess, you can check out... Oh, where is it? You can check out my walkthrough documents over here. So every challenge I do, I record, and I basically take a bunch of notes. You might want to check it out. Okay, so hex digit, low nibble, F, high nibble, nibble, Okay, where were we? So 6-3. So if the digit is 6-3, we have to convert this to like a hex digit. So 6-3 is... I have a hard time doing conversions. Decimal to hex. So we've got decimal number 6-3, convert this to hex. This is 3F. So that means the low nibble. Low nibble is F, and high is 3. Okay, nullsec says CyberChef. I mean, we could do this in CyberChef as well. So we got 255 and then convert to 2 base, I think. 2 base. Put it in here. You would do radix 16. Yeah, so radix 16 converts 255 to hexadecimal, which is FF. But we're not looking for... We're looking for the digital equivalent of this, right? So F, low nibble equals F equals 15, because F is 15 in decimal. Same thing here. So this would be this is also 15, and 3 is... I mean, 3 is just 3, so 15 and 3. Yeah, 3 and 15, and then we've got 11, high nibble 0, low nibble 11. Okay, so I guess we just need to define what the low nibble and high nibble are. So low nib and high nib. They gave us the formula for like bit shifting. We might want to know, is it bit shifting or is it like another bitwise operation we're doing? Somebody suggested something, right? Okay, do a bit shift, right? Bit shifting. So let's see. low nib equals 8-bit int shifted by so these are both going to be right shifts. So right shifts are divisions. Wouldn't call those bytes anymore. Byte standardized to 8 bits a long time ago. So bit shift by 1. And then, so is it bit shift by, this is bit shift by 2. And the high nibble is 8-bit int bit shifted by 1. I think, or at least I think that's what that's how it's going to go, right? I should try doing a little bit of debugging here. So we'll print f. Don't forget to declare the high and low variables. Okay, like a binary, Sircat says 11 in binary is 1011, but the high nibble is 0 because we take the right, and the low nibble we take the left bits. The right bits, the left bits. Okay, so let's just try printing something out first. Low nib. Oh, we're printing out the high nibble first. So H high nib. And then the low nibble. Try shifting by 4. Up one way, down the other way. Try shifting by 4. I mean, let's just see what happens. But so we're shifting by 1 and 2, so it's probably not exactly good enough, but we'll see what kind of results we get. Okay, so does the code work? Run the code. Low nib undeclared. First use in this function. Undeclared. Oh, okay. We need to make sure that these are both integers. Yeah, okay. Format expects the type integer. This is line 8. D 8-bit int. Oh, sorry, we need to put this in because we're doing the assignment. Never declared high and low variables. Low, high. Okay, enter a number between 0 and 255. So if we do 255, high nibble is 127, low nibble is 63. Okay, so let's do... So we're shifting over. Let's think about this. Let's just think about this. We're doing like a big shift. So if we're talking about this 8-bit number, it's 1, 2, 3, 4, 5, 6, 7, 8. And if our number is 255, then the bits are all like this. So this is 255. And we're looking for... We're now looking for the high nibble. So the high nibble means we need to eliminate 4 of them to get 1/2. So I guess, yeah, you were talking about like shifting by 4. So if we shift by, we do a right shift. So we do a right shift by 4. So that would result in 1, 1, 1, 1. So this is so this is 8. 8 plus 4, 12. 12 plus 2, 14, plus 1, 15. So this is 15. So better off using a character variable type, 256 only. Character variable type. Maybe. So the high nibble we right shift by 4, and then the low nibble so if we right shift by 4, we eliminate all of these. So in this case, we want to eliminate So shifting by 4, I mean, it can't be... So for the high nibble, we right shift by 4 to get rid of everything but this, right? You can't shift to get the low nibble, you need to use the mask. Oh, okay. You need to use the mask. So we need to... right shift by 4 to get the high nibble. To get the low nibble, we need to use bit mask. Bit mask, and is it like... What's the operation we do with the bit mask? It's the bit mask... Is it the bit mask and the bit mask, or the bit mask or? Bit mask and this one. Right, bit mask and the value and 0f. Right, so in this case, the bit mask is the last 4 digits. So the last 4 digits would be 15, right? So 15 bit mask for last 4 bits, because that's going to be these digits right here. If we're talking about, like, if we're just talking about like an 8-bit number. 15 for 0f or 0b1111. So the high nibble is 8-bit number right shifted by 4, and the low nibble, I guess we also need to define the mask. Int, we'll call it low nib mask equals 15. So low nib equals 8-bit integer, and then AND operator on low nib mask, like this. Okay, Comrade Soul, hello, nice to see you here. Hope you're having a good time. I hope this is the correct syntax. All right, let's go ahead and try this again. Okay, enter the number, so 255. high nibble is 15, low nibble is 15. So it seems to be working. We'll try the other inputs and see if they come out okay. Then we'll put in 63. High nibble is 3, low nibble is 15. And 11. So it should be high nibble is 0, low nibble is 1. Sorry, 11. Okay. High nibble 0, low nibble 11. Okay, so it seems to be working. Great, we can move on. Seems there may be multiple ways to accomplish it. Yeah, well, I mean, this is programming, and there's like as many, well, there's a lot of ways to solve the same kind of problems in programming, yeah. You reached the end of Module 3 and completed a major milestone in programming education and learning of the fundamentals of C. Okay, conditional execution and the else branch, data type modifiers, conversions and typecast, loops and flow control, statements, logical and bitwise operators. Okay, well, I guess they want us to do like a quiz? Sure. Many cats, many skins. Okay, code of honor. I guess I will take a test. 20 questions. Sorry, 20 minutes, 10 questions. Okay. What happens if you try to compile this program? Compile and run this program. So let's see. Int main void. Int I equals 100. Okay, so they're looking for one of these three answers. So the program outputs 100, the program outputs 0, the program outputs 200. So what's going on? So I starts as 100. If I is greater than 100, then decrement by 100. So this doesn't happen. Else, if I is greater than or equal to 0, then I increments by 100. So I is now 200. Else if I is a positive integer, I'm guessing, it's incremented by 100, else I is decremented by 100. What is I? That's a good question. So I mean, it looks like if else, I mean, this gets activated first. No. This gets activated first. If I is greater than or equal to 0, then I is incremented by 100, and then the rest of this doesn't apply. So the program should output 200, because this happens and then the rest of this doesn't happen. Next question. Okay, what happens if you try to compile and run this program? So we're looking for 1,100 or 500. I hope it's correct. Okay, so integer I equals 100. If I is greater than or equal to 100, okay, so it is. I is incremented by 100, so I is now 200. If I is greater than or equal to 0, I is decremented by 100. So it increments by 100 and decrements by 100, so it is still 100. And then after the if, then I is multiplied by 5. So it's 100, then it's multiplied by 5. So it should be 500. Or at least I think it's supposed to be 500. We'll see. Okay, so what happens for this program? So 1L, 1L, so lowercase l, uppercase L. The program outputs 11L, the program outputs 2. Okay, so long L, integer I. So this is a long integer L, standard integer I. L equals L 1L plus 1L. So, I mean, these are supposed to be interpreted as... These are not characters. So these characters are supposed to be interpreted as numbers. So I equals L. Print I. 1L plus 1... So I equals L. So we only have to care about what L is. L is 1L plus 1L. So the program could output 2 or 1L. 1L. This doesn't make sense. So it can't be this. So characters are interpreted as... They should be interpreted as numbers. But for some reason, like, the program outputs 2, this doesn't seem correct either. So I'm guessing that this is the answer. I'm not actually sure about this. Okay. So the ASCII code of $sign is equal to 36. So what happens if you compile and run this program? So it's gonna output. So is it going to be a float? I guess it's going to be a float in all these cases. We have integer I, but L in int, maybe ASCII. Yeah, maybe it's interpreted as an ASCII number. Okay, integer int, character char, short, float, float. So integer 100, character $sign. So $sign is 36. Short equals character. So short equals 36. Float equals 0.5. Integer equals... So we're reassigning this. Short plus character plus float. So so 36 plus 36. 36 plus 36 is 72, plus float, and float is 0.5. Short plus character plus float. So 72.5. Float equals int. Float equals int. Float equals int. Print float. I mean, my guess is it outputs 72.5 as a float. Float equals int. Either it's 72.5 or $72 plus 72. First answer is wrong. Oh, the first answer, So 100 int equals short plus character plus float. I mean, this is assigned as 100, then it's reassigned as short plus character plus float. Float equals int. So float equals 36. No, sorry, 36. So the $sign is 36. So it's like 36 plus 36. 36, 0.5. Integer is a whole number. Cast to float doesn't bring the 0.5 back. Oh, it's cast to a float. Okay. Print F. So the float... No, I mean the integer. So int in this case would be cast into a float because a float has been introduced. Which means that the program is going to is going to have a bunch of decimal output. So my question here is where do these values change? So this is int is 100, and then int becomes 36 plus 36 plus 0.5. So it's 72.5. Float equals int, and int is 72.5. My gut tells me that it's this, but I guess we'll figure it out. We need to move on to the next question. Okay, what happens if you try to compile and run this program? We've got 5, 7, or 9. So integer I equals 1, j is 0. So while we've got a loop. While I is less than 111, j is incremented, and then I is multiplied by 2. I is multiplied by 2. So each time the loop runs, I is multiplied by 2. So this would run how many times? So it's 2, then... Hold on, let me just... quick math. So I equals 2, then 4, 2, 4, 8, 16, 32, 64, 128. So how many times is this? 1, 2, 3, 4, 5, 6. So the loop gets to run 6 times because it doesn't run when I is 128. So 6. So j equals 0, j increments. It happens 6 times, the program outputs 5. 7 times. 7 times? So while... So it runs the first time. Okay, I thought I was going crazy there for a second. Anyways, let's move on. Okay, so we've got 5, 3, and 7. 5, 3, and 7. So I equals 0, j equals 100. 4, I equals I, j, I plus plus. So I is 0. So I is 0. J is affected, and then I is incremented. J is divided by 3. J is divided by 3. So how many times does this run? I equals I plus plus. Oh, I think we're trying to match until I is equal to J, because the stopping point is J. So J decrements and I increments. There's no stop condition. The stop condition is... Does it... Well, I mean, it doesn't say that it... There's no option that says it goes on forever. Not until I equals J, until J is false. Until J is false. So until I is equal to J, basically, right? So we go from... So I increments with each loop, but J is divided by 3. So 0 and 100. I 0, J is 100. Okay, and then I is 1, and J is 33. because this is integer division, which means it's divided by 100 divided by 3 is divided by 3 is 33. No, j divided by it's 5. 5. Hold on, let's take a look at the code again. J is divided by 3. So if we split 100 into 3, then it's 33, right? So after the first iteration, I is 1 and j is 33. Then I is 2 and j is 11. Then I is 3 and j is divided by 3. So it's 3. So I and j become the same thing, and then what are we printing out? So printf I becomes 3. So it should be 3. Well, I only have 5 more minutes to answer the rest of these questions, so I'm just going to go with 3. We'll see if it's correct later. Okay, so we've got integers I and j. For I equals 100. I is less than or equal to 100, okay? And I iterates by 1. J equals I. We print out j. J equals I. So the program is going to output either 99, 100, or 98. So the first time it runs, I is 100. We're checking if I is greater than or equal to 100. I increments. J equals I. So this only ever runs once, right? So this means that that j has to be 100, because j becomes I. Okay, so this is this is my guess. I might actually fail this exam, but we'll see. We'll see. Okay, so here we've got the options 101, 100, and 99. So I is negative 100 and j is 200. Print out I plus j. I plus j. So if I is greater than 0 and j is less than 0, if I is greater than 0, no, and j is less than 0, no. Else if I is greater than 0, no. No, wait, if I is less than 0, yes. And j is greater than 0, yes. I decrements. So I decrements. I decrementing, does that mean that I becomes negative 101? So I becomes negative 101. So the rest of this doesn't apply, so negative 101 plus 200. So that is 199, 199, 99. So the program outputs 99. Okay, let's move on. We only have 2 minutes left. So program outputs 2, program outputs 1, program outputs 3. So integers I, j equals 3. So I equals decrement j. I equals decrement j. So I equals 2. J increments by not I modulo 2. Not I modulo 2. So this is I modulo 2 is true, is false. So this is true. J increments by 1. I decrements by 1. J increments by 1. Decrement of J. So, but J decrements by 1, which means that J is 2. J is 2, and then J. So I think this is 3. Last question. Okay. So program outputs 0. Oh, we only got 30 seconds. 0, 1, and -1. Okay, so integer I equals -1. J is minus I. Negative I. So I is positive 1. Print W1 is equal to W2. So this is going to be either true or false, so it's 0 or 1. Time, this. Submit. Damn it! I only got 50% correct. You don't have enough correct answers to pass the quiz, try again. Okay, so let's take a look. Let's review the test. Submit random, yeah. Okay, so program it outputs 200, we got this one correct. Output 500, we got this one correct. Okay, so this one is supposed to be 2. So I guess we need to understand, yeah, which 50%. So this one here, we had a problem trying to figure out what L was. So L is 1L plus 1L. You know what we can do? We can copy this code, and then we can run it ourselves. So let's see. C compiler online. So 1 plus 1 equals 2 equals L. I tell you that maybe it's ASCII. I mean, it's probably ASCII. So we're printing out I in this case. So I, what was it again? Long L int I. Long L int I. L equals something, and I equals L. Okay, so it was like 1L plus 1L. The question is 1L. Oh. So yeah, 1 lowercase l plus 1 uppercase L. Then print out I. Okay, if we just run it like this, what happens? Okay, this prints out 2. So 1L. 1L. So the question is, why does this print out 2? How is this interpreted as... How is this interpreted? 1L plus 1 capital L. So 1 capital L is 1 plus... Control C, Control V. Use Python tutor to see step by step. 1 plus 1 equals 2, regardless of its long int status. Yeah, use Python tutor. Python tutor. So I guess the question we should be asking here is, in C, what is the meaning of L and L after an integer? For example, 1L or 1L. So appending L or L to an integer literal, 1L or 1L, tells the compiler to treat the number as a long integer type rather than the standard integer. Okay, so that's what was happening there. So this wasn't ASCII, this is basically like a denotation that tells the compiler that this is a long integer. We can use either one. It prints 2 because 1 plus 1 is 2. 1L just means that 1 as a long, so basically adding long 1 plus long 1. Yeah, that makes sense. So it's like L, like in C#, where it specifies that the number should be treated as a long and non-normal integer. So C converts automatically between integer types if it's the other format. Okay, so this is I forgot about the notation, so that's why I wasn't able to finish that. So this should be number 2. Okay, so next question. So the program outputs 72, so it drops off. So it still gets cast as a float. It still gets cast as a float, but it drops off the 0.5. So I think MKR Rocks, hello. Nice to see you. I checked out the Moodle labs. The Moodle labs and the AWS ones, but they are different. Were we talking about Moodle? I'm pretty sure we were talking about like Pwned labs when we were talking about learning about AWS. Okay, so where does this get chopped off? So integer 100, right? And then it gets overwritten by short plus char plus float. Short plus character plus float. So, I mean, I guess the fact that this is still an integer means that it will not return. So the 0.5 is chopped off. So it's just 72 at this point, and then float becomes int, so it becomes 72.00000 when we print it out. Okay, so now that makes sense. Okay, so we got this one wrong as well. Program output 7. So we thought that the loop would only run 5 times, but it turns out that the loop runs 7 times. The expression short plus character plus code is cast to float, but it won't change the type in the integer. The matrix is real. Hello, and it's nice to see you here. Wait, it's showing 2 live stream. 2 live stream? Are we doing 2 live streams right now? Hold on. Let me check my YouTube page. Oh wow, there are 2 live streams. That's kind of weird. Yeah, I don't know why that is. I scheduled 1 live stream, but for some reason 2 live streams are going on at the same time. I wonder if I can stop one of the live streams without stopping both of them. Because it's weird that people are split. Still bugged from the other day? Maybe. Yeah, I'm gonna have to investigate this after the stream is over. Thanks for calling it to my attention. The Matrix is real, thank you. Okay, so apparently this loop runs 7 times. So I is multiplied by 2, while I is less than 111. J is 0, so print out J. So while I is multiplied by 2. So let's go back here. So in this loop, the first time it's run, I becomes 2 and j becomes 1. Then I becomes 4 and j becomes 2, 3, 4, 5, 6, 7. But it shouldn't run the 7th time. Okay, I is 1 the first time, but I mean but j is 0 the first time. I'm talking about what the results are after the loop is run. So after the loop is run, j increments. So the while loop checks after this is all done. So after I increments the last time, and becomes 128, then j shouldn't become 7. Two, 4, 8, 16, 32, 64, 128. Yeah, it should check after the loop. Yeah, it should check. It checks after the loop, or it checks before it runs the loop. Okay, we'll settle this. I can't copy and paste this, so it doesn't let me. Actually, I wonder if I can. Yeah, I can't even. I'm pretty sure I can't get the code from this. Yeah. No, j is 0, not 1. J is 0, not 1. So j starts as 0. So before the loop runs, we run it the first time. J becomes 2. J becomes 1. And then I becomes 2. You could print both values inside the loops. Yeah, we could. Let me, hold on. Let me try writing this. Okay, I'll try just copying the code. Int main int I equals 1, int j equals 0, while I is less than 111. J plus plus I times equals 2. And then at the end of the program, printf. Oh wait, should be in here. Printf j return 0. Okay, let's just try doing this. We'll put it in our C compiler. Then run it. 7. Okay, so it does output 7. I guess we could we can print. We can print F after each one of these, just to see what the values are. J is now %D. And then here we'll just do printf I is now %D. And we can put some line breaks in there. Okay, it prints before. The numbers you calculated were right. They were the correct values at the end of each loop. It'll be 7 because the first time it's 1, so it's iteration 1. Let's see. Python tutor can understand how the code is running in the heap in the stack. Is Python tutor only for Python, or is it for multiple languages? Okay, so we'll run this code. Okay, J is now 1, I is now 2. J is now 2, I is now 4, J is now 3, I is now 128. So I becomes 128, and the next time it doesn't run. Oh, okay. All right, I was a bit confused, but this makes more sense. All right, let's go back. Okay, next question. We got this one wrong as well. So this program is supposed to output 5. Integer I equals 0, integer j equals 100. So we divide j by 3 each time. So for I equals I, j is the stopping point. So I and j have to be the same number. Okay, let's do another 60 minutes. And after 60 minutes, we might have to call it a night. Okay, the matrix is real, like iteration 1, 2, iteration 2, 3. So like Anarchist says 100 and then 33 and then 11, then 3, then 1, then 0. So 5 iterations. 5 iterations. So each time j is... Oh, so j has to become 0. J has to become 0, and I remains the same. But I is also incrementing. So with each loop, it runs for 5 iterations, but does it update? It updates the global value of I after the loop is done. Okay, and Hadgad Ma, nice to see you here. What is your job in cyber? My job in cyber is education. I'm teaching people online. I used to work as a web app security tester. Okay, so let's here's my cybersecurity resume. Okay, so 5 loops. 5 loops. So after the for loop, the value of I is... The value of I remains changed. So I actually becomes 5. But J... well, it's a bit confusing. So the program outputs 7. So we're printing out the final value of I. Okay, it'll never become 0. Okay, so Had Gadma says I'm currently backend intermediate. Oh, okay. So you're like, what is considered an intermediate role? How many years of experience do you have in your backend role, Had Gadma? Okay. You also teach University Python. Well, that's awesome. Okay, so we just have to keep in mind that after the for loop, the I value is modified. Okay, next question. So we got this one right. We got this one right. And we got this one right. But we got a bunch of problems in the middle wrong. Okay, let's try to retake the test. Okay, so we got 20 minutes. This is... I mean, I guess the questions are the same each time, right? So I equals 100. If I is less than 100, then I is decremented by 100. If I is greater than 100, so it's not, I is greater than 0, so it's incremented by 100, so the program outputs 200. Ty Grail, hey, nice to see you here. Don't go fast. Well, I'm intermediate because all I do is CRUD API work, nothing magical. I mean, do you have fun at your job? maybe not. Okay, so I is 100. I is 100. If I is less than 100, less than or equal to 100, then I increments by 100. Greater than or equal to 100. So I is incremented by 100, so it's 200, then it's multiplied by 5. If... Oh no, it's incremented by 100, then it's decremented by 100. And then it's multiplied by 5, so the program outputs 500. Okay. These look like the same questions. So we just need to learn from our mistakes. So the program outputs 2. Okay, and then here we remember that the 0.5 is chopped off, so so this is the answer. Hadgadma says, I'm seeing the AI and I don't know if I should do cyber. I like cyber, I do try hack me, but I don't know if I'm going to find a job in cybersecurity. I mean, what I'd do, Hadgadma, do you live in a big city? If you live in a big city, what I would do is I would try to find people who, like a cybersecurity meetup. Most large cities should have like a weekly or a monthly meetup for cybersecurity professionals. And if you attend those in-person meetups, you can start talking to people. If you talk to them, you can ask them questions about what they do in their daily job, and maybe you can make a more informed decision after that. Okay, so what was this one? This one was program output 7. No, this was outputs 5, right? Because we were taking a look at this thing. Yeah, J is now 5. Okay, so this was J is now 7. This was the 7 question. Okay, this is the one where J is divided by 3. Thanks for the advice. I mean, if you tell me which large city you live nearest to, I might be able to give you some. I might be able to give you some suggestions as to where to look for the in-person cybersecurity meetups. And what kind of backend do you do? Is it mostly like web application stuff? If it's web application stuff, then you might want to look into like web application security. I've got a bunch of education links over here if you want to take a look at them. Okay, so program output's 5. So this was integer ij, for I equals 100. I is greater than 100. I increments. J equals I. So this only runs once. So J equals 100. Okay, Tigerel says, saw the post in my feed and followed it in LTNS. Been busy, but I catch vids where I can. Happy to see the coding. Checked out LeetCode, the LeetCode video. Yeah. We're having a lot of fun figuring out LeetCode. Algeria, North Africa. I think I might have something for meetups in Algeria. Try hack me in Dallas tomorrow. Really? That's on. I mean, I hear there's a lot of big cybersecurity meetup groups in Dallas, Fort Worth. So in my education resources over here, we recorded a bunch of like in-person cybersecurity groups, IRL cybersecurity meetups. I think we might have recorded one for Algeria. No, I guess not. But you might want to take a look at this. Web application, coding, or security? Yeah, I mean, Hadgadma was talking about being a backend developer, so it's coding, right? So negative 100. So I decrements. So minus 101. Minus 101 plus 200. So 199. 199 and then 99. Okay, so I and J are 3 if I equals decrement J. So decrement J is 2. 2 increment not I modulo 2. So I modulo 2 is 0, it's false, but it's true, which means that J decrements and then increments, so I is 3. So J is 3. Okay, so this is the one that we were... How about Germany? I can move there. Germany? I mean, there's... The cybersecurity scene in Germany is really big, especially if you're talking about like large major cities like Berlin. Do you teach like a code camp? Well, I mean, I teach some courses for teaching people about CTF skills. So I teach courses. Let's talk about this. So I teach like beginner CTF courses. I teach like Linux basics, Python basics. I teach web app hacking basics, so you know, basics in a bunch of different stuff. I teach digital forensic basics, network hacking, Is there just anything in cryptography basics? So I teach a bunch of different programs that teach basics about different concepts. So Linux, Python, web app, digital forensics, network hacking, cryptography. I'm trying to teach myself more about reverse engineering and binary exploitation so I can teach that stuff as well. But this is what I teach right now. Okay. Joaquin Curay? I'm not too sure how to pronounce that name. You can divide 105 times by 3 until 0. Oh, yeah. What job can I get if I know all that? How much of a salary can that get me? I mean, if you're... The other thing you could do, if you know about, like, if you understand web apps, and you learn about web app hacking, like, you learn about different web app attacks, you could potentially do, like, a side job in bug bounty hunting. This isn't something I recommend to people who don't know very much about app development, but if you know app development, it should be a lot easier for you to learn about web app attacks, and then maybe do something like bug bounty hunting as a side job. I wouldn't recommend it as a primary job because bug bounty hunting can be very hit or miss. Oh, 12 minutes behind, okay. So if you're interested in cybersecurity, focus on coding, there's a very strong school around the world called 42 School. It's free and starts with C and C++ after that. 42 School. I've never heard of this one. Let me look it up. Are you talking about the Global Tuition Free Tech School? 42network.org? Hadgodma, so like HackerOne, that's one of the programs. I think there are different programs. I think HackerOne is the most famous, is the most popular one. You used to teach and it's a good resource. What are we talking about? So Tigrail, let me catch up with your messages. Blaze mentions them on occasion. Try hack me in Dallas tomorrow. So Tigrail, which school or which website are you talking about? Okay, so we still have 8 minutes here. Okay, so I think the program outputs 1. I think that was it, but what's going on here? So I equals -1, j equals -I. So -I is +1. So I is -1, j is +1. Integer wn2. So we just need to make sure that these are the same number. So w1. Oh, Blaze. Wait, Tigrail, do you meet BlazeBits in person? No, no worries. I'm here to get off topic if we're talking about something fun. Okay, so W1 is I is greater than 0. That's false. And J is... So this is false. This is false. Or I is less than 0, true. And J is greater than 0, true. So W1 is 1, because this is true, because this is true. W2 is I is less than or equal to 0, false. Or J is greater than or equal to 0, false. And why does this... Hold on. Okay, so let's catch up with chat. Bug bounty hunting is also more dicey now with AI, so HackerOne suspended to figure out what to do. So, like, is School 32 in Canada still open? I haven't heard of it before. Tigrail says, I haven't got to meet him yet, but he's in my somewhat area. I mean, Texas is really big. Even if you live in the same area, Texas is really big. Roadmap.sh cybersecurity. Awesome, you know how to circumvent the filters, Tigrail. Henky, hello, nice to see you here. I see you stream more longer than usual. I mean, I started a lot later than usual as well. So these are my short streams. They usually go for about 3 hours. Roadmap.sh/cybersecurity. Yeah, let me bring it up. Roadmap.sh/cyber-security. Funny, I don't see it. Maybe I should just look up like roadmap.sh. Okay, here we go. So there should be one for cybersecurity. I think we have this on our Get Into Cyber page, where everything is bigger. Everything's bigger in Texas. Get Into Cyber. There you go. And you can also check out this one. But anyways, let's just finish off the let's just finish this off. Sit down. Are you sure you want to submit your assessment? Clicking yes, your session will end. Your answers will be submitted. Okay. 100%. Awesome. This is kind of intense music, true. Okay, next page. No worries, no worries. I'm happy to help and happy to share resources. Okay, Hack the Box doesn't provide GUID. So what I'm thinking is to get good with try hack me, then occasionally try hack the box until it gets easier for me. I mean, what I would suggest if you want to get into web application security specifically is to just take a look at all the labs over at Portswigger. So Portswigger has a web security. Well, Portswigger is all web security. If you want to get better at doing web security specifically, I'd stick to Portswigger. If you can do all of the labs, and you can get, if you do all the labs and you are able to get this certification from Portswigger, then you're overqualified to do web app security testing. Didn't I already do this? Didn't I already do this? Oh, these are different questions. Oh, this is 20 questions. Oh, okay, jeez. Okay, so what is the program output? J. I and J are 1. For I is 11. So I is 11, I is less than 0. I gets divided by 3. J increments. Okay, so let's think about this. It's not 1, it's 0. Have you seen OT Security Resources? That's a pet project of mine. OT Security Resources. I mean, I've got a short section on... I've got a very short list of ICS hacking stuff, so industrial control systems. It's not very much. It's just a few different try-hack-me rooms. So j increments, but I is divided by 3. So 11 divided by 3 is 3. So it runs at least once, and then it runs again. So I'm guessing that the loop happens twice. So the first time, after the first loop, I is 3, and then I is 0. So the program outputs 2. Okay, trying to put together a potential degree plan. A degree plan? You mean a program that you would teach at a university? Or a program... can you explain, Tigreal? Okay. So print j. So j, I and j are 1, while I is less than 16. I increments by 4, j increments by 1. So so j is 2, and I is 5. Then I is 9, and j is 4. No. 2, 3. And then I is 13. I is 13 and j is 4. And then j is 5. So the program outputs 5. Nullsec is passing out. Have a good night, everybody. Have a good night. Have a good night, Nullsec. 2 is wrong. I guess we'll figure it out and after the test is over. Hold on. Okay. Okay, so we print out I. I is 1. While I is less than 16, I is multiplied by 2. While I is less than 16, I is multiplied by 2. So I becomes 2, then 4, then 6, wait, 2, then 4, then 8, then 16. So I becomes 16, at which point I is no longer less than 16. So this prints out 16. Okay, Tigreal says associate's degree. Oh, okay. So you're writing a college program. I mean, what's the program going to be called, Tigreal? Okay, so we're printing out j. J is I is 7. J is I minus I. While not I, so while not I is... Not I means I is not 0. While I is a positive integer, I is divided by 2, and then j is incremented. So j is I minus I. So I is 0. So I is initialized to 0, and then I increments. So j is 0, then j increments. So j becomes 1, and I is divided by 2. So 7 divided by 2 is... 7 divided by 2 is 4. and then it's 2, and then it's 1, and then it's 0. So by then, j is 4. But that's not an option, so let's go with 3. Okay, Tigerel says, my previous employer just partnered with Google to offer an NEI associate's degree, but the security side is a bit small. Okay. I'd like to see a full degree plan for OT ICS security, as it's so integrated in our lives today. It doesn't round, it truncates. Oh, it doesn't round, it truncates. So 7 divided by 2 equals 3. So we need to round down before we do the math. Anarchist? Okay, this is good to know, because I'm not super familiar with integer division. What happens if you try to run this program? We're printing out k. So I is 1, j is minus 2, and k is... what is this? So k is either 1 or 0. K is probably 1. So I is greater than or equal to 0, true, and j is greater than or equal to 0, false. So this is false, so this is 0. Or false. I is greater than 0, greater than or equal to 0, true, and j is greater than or equal to 0. J is greater than or equal to 0, so this is, k is false, so k is 0. Okay, what do we got here? We're printing out j. I equals 1, j equals minus 2. 4, so this is an infinite loop. If I is less than 30, if I is greater than 30, break. I gets multiplied by 3, and then j is incremented. So j is minus 2. First time it runs, it becomes minus 1, and then I is multiplied by 3. So I becomes 3. I becomes 3, then 9. So the second time it's 9, and j is 0. The third time, I becomes 27, and j becomes 1. And the fourth time, j becomes 2, and I becomes some other big number that's greater than 30. So the program outputs 2. Okay, interdivision drops the float part. It drops the float part. Okay, so you divide and then you drop the float. Okay, move on. What happens if you run this program? So we're putting out k. So I is greater than or equal to 0, true, or... So this is true, and I is less than or equal to 0, false, or j is less than or equal to 0, true. So true and true. So k is 1. Yeah. Okay, and next, we're printing out k. K equals I bitwise and j. So 1 bitwise and 0. So k is 0. K is 0, and then k bitwise or not k. not k? Sorry, I must be going crazy here. So k equals 0, and then k is not k. K or so k is 0, not k is 1, not k is 0. So it seems like k is still 0. Okay, now we're printing out k again. K equals I, bit shift J. So we're doing bit shift J. So I bit shift by J. So we're doing a left bit shift. So what happens if we bit shift 0 though? So 0 bit shifted is still 0. Plus J bit shifted by I. So J bit shifted by I is 0. So K is 0? Because you can bit shift to the left 0 all you want, but you still get 0. Okay, we're printing out K. K is not I greater than or equal to 0. True. Or so K is 1. So this is true, but this is false. So this is false. J is greater than or equal to 0. J is not greater than or equal to 0. So this is true. And I, not I, is less than or equal to 0. True. So this is K is 1. Okay. Lovejoy, hello, nice to see you here. Hope you're having a good time. Okay, so what's going on here? We're printing out K. So K equals I XOR J. I XOR J. So I, 1 XOR J. So any number XORed with 0 is the number itself. So this is 1 plus not I XOR J. Not I XOR J. Oh geez, this is getting complicated. So I XOR J is the number itself, so that's 1 plus not I is 0. 1 plus 0 plus 1 plus 0 plus 0 plus 1. So 1 plus 1. So K is 1 plus 1, so the program outputs 2. Yeah. I got that eventually, Anarchist, thank you. Okay, so we're printing out J. Let's see. I and J are 0. For I equals 0, not I, increment I. So I equals 0. Increment I at the end. Not I. So not I is 1. Not I is 1, because I is 0. So this happens once. So J is 1. Okay, next one is print K. K is I plus J. Oh boy. Okay, so I is 2 and J is 3. If J, okay, then J. If J, then J. Okay, else if J, then J. So J is J. J is J. So J is 3. I plus J. So it's 2 plus 3, so K is 5. Why are you doing this to me? Okay, so next we've got print X, float X and Y. We're printing X. X equals 1.5. Y is 2. I is 2, J is 4. X equals X times Y. So X times Y is 3. So 3 plus the float of J divided by the float of I divided by J. The float of I is 2. Divided by J is 4. So 2 divided by 4. 2 divided by 4 is 0.5. 0.5 plus 3. So 3.5. But X is a float, so this works. So it's 3.5. Okay. Okay, we're printing out K. K. K is I times J. I is -1, J is 1. If I, but not, this doesn't happen, okay? So J decrements. J does not decrement because I is negative. If J, actually wait, so if I still works, no, if I still happens, right, because I is not 0. So if I still works, so J does decrement. So J becomes 0. If J, so J, I increments, but this doesn't happen because J is 0. So these still have their original values. So K equals I times J. So -1 times 1. -1 times 1 is 1. Truthiness is it equal to 0? Truthiness is not equal to 0. So K is -1 times 1. So -1 times 1 is 1. Okay. K. K again, huh? Okay, well. So I plus J. K is I plus J. I is 0, J is 0. If J, but if it's not J. else I increments. So I becomes 1. If I, and I is... Actually, wait. So the if... Yeah, this is the if and else are treated as separate blocks, right? So I increments, so I becomes 1, and then if I, then I decrements. So I is now 0. So I plus j, they're both 0. The program outputs 0. Wow, I'm getting really tired. This quiz is killing me. Okay. So print I. Double x equals minus 0.1. Minus 0.1, okay. I equals x. Integer I equals x. So minus 0.1 when cast into an integer is just going to be 0 because it's an integer. So the program outputs 0. J. I equals 7, j equals I minus I. So I equals 7, j equals 0. While I is not 0, I is divided by 2. Okay, I is divided by 2 and j increments. So j is 0, j becomes 1, I becomes 3. And then j becomes 2, and I becomes 1. And then j becomes 3, and I becomes 0. So j is 3. Oh man, my brain's getting fried. Okay, so print x, float x, y, integer I, j. X equals 1.5, y is 2.0. I is 2, j is 3. X equals x times y. X times y, so x times y is 3 plus I divided by j. 2 divided by 3. What happens when 2 is divided by 3? Two divided by 3 is math. 2 divided by 3. Hold on. It's way too late. So let's just pretend this was like, I don't know. They're float here because some are float could be wrong. So this is integer division, I'm pretty sure. So 2 divided by 3 is, normally it would be, I mean, we could do like 20 divided by 3 would be 6 point something. It's 0 point something, but that gets rounded down to 0. So x times y, so it's 3. And these are floats, so it's 3.000. Alright, last question. Last question, we're putting out k. K is not k. K is not k. Okay, integer I equals 1. J equals 0. K is not I. So not I is 0, or... Oh, this is a bitwise operator. So 0 or J. J is 0. 0 or 0. So 0 or 0 is 0. Not K. Not K is 1. So K is 1. Okay. I'm gonna fail. Oh man. I don't feel good about this. 85%. Actually, that's not bad. 17 out of 20. Missed 3. Okay, let's review the test. After we review the test, we can wrap up. So the program outputs 2. Incorrect. Wait, what? It says that this one is incorrect. So I equals 11. I is greater than 0. I is divided by 3. So I said that it's supposed to be 2. You forgot that J starts at 1. J starts at 1. So J becomes 2, and I becomes... So it's 11 divided by 3. So 11 divided by 3 is going to be... Three point something. It's going to be 3 point something, which becomes 3. So that becomes 3, and then J becomes 3. Ah, okay. So the program should be outputting 3. Okay, next. This one's correct. This one's correct. This one's incorrect. Okay, what is this? So J. Print J. J equals I minus I. So J is 0. And I is 7. So while not I... While not I... So while I is... So not I is 0. While I is not 0. While I is not 0, okay. So while I is not 0, I gets divided by 2, and J gets incremented. So after the first loop, J becomes 1, and I becomes 3.5, which is 3. Then J becomes 2, and I becomes 1.5, which is 1. And then J becomes 3. And then I becomes 1 divided by 2, which is 0.5, which becomes 0. So, I mean, I think it should be 3, but apparently this should be like 2. Beyond hard for me. I mean, we just have to challenge ourselves and try to get better at this stuff, right? Okay, this one's correct. So we've got one more incorrect question to look through. I'm really surprised that I got most of these correct. Because I'm actually not very confident about my math skills. Okay, K. K is I times J. I times J. I guess that the program outputs 1. So let's see. I is -1, J is 1. If I, so if I qualifies, and then J is decremented, so J becomes 0. If J, so this doesn't work. If J, so J becomes 0, I times J. So it's -1 times 0. -1 times 0 is 0. Oh, the program should output 0. Okay. Alright, my bad. Yeah. I see it now. Okay, back to summary. Okay, we passed the test. Okay, since we passed the test, we can move on to the next section, right? I'm not going to retake the test. Okay, we move on. And we can move on to Module 4. So what is this? So we got switches. So switch statements. So different phases of if, arrays and vectors, sorting in real life in computer memory, initiators, pointers, addresses, references, and dereferences. Oh, we're doing pointers. This is another pain point in C. We have to understand memory pointers. Okay, simple pointers and pointers to nothing. And operator, pointer arithmetic, pointers versus arrays. So this is where people get stuck with C programming if they're coming from languages that don't deal with memory. Persona management. Oh yeah, I didn't know this was on right now. I'm going to stay up late to watch the whole thing. Thank you very much for these coding courses. I wouldn't call them coding courses. It's just me fumbling through a coding course and trying to learn stuff. But yeah. Alright, so we've made it to Module 4 out of 8. So we're basically, after we finish this, we'll be halfway through. This was very tiring. Alright, so we've got a few minutes left. Well, let's just talk about what we're going to be doing next time. So this was... Oh wow, tomorrow. We've got a stream tomorrow, huh? Okay. So let's see. So this says Order of the Sinking Star for a puzzle game tomorrow, but I'm probably not going to be doing that, because I found a much more fun-looking game. So we found a game that is called like Desktop Explorer, I think. So this is basically a like computer-based puzzle game slash horror game, and I'm gonna try out the demo on stream. This looks like a lot of fun. You get to explore a virtual desktop, solve some puzzles, and then, you know, lots of spooky stuff. Anarchist says, I think pointers are actually easier than all the weird arithmetic logical stuff. Well, I guess I'll find out. I guess I'll find out next time. But yeah, that's going to be a lot of fun. We're going to be doing that. We're going to be doing a demo of the Hack Me Machine Kenobi. So this is a very easy like network hacking exercise. I'm going to be walking through it. We're going to be talking about network hacking session number 10. So this is the last network hacking session. We're going to be talking about privilege escalation. So specifically, we're going to be talking about stuff like path hijacking, cron job, abuse, and script hacking. That's going to be the third topic. The last thing we're going to be doing is we're going to be doing a CTF box that we haven't done before. It's called Gotham, and it's from the Docker Labs platform. It's going to be a lot of fun, so please check it out. Turnip says, I find pointers easier. They're a little confusing at first, but it starts to make sense. Yeah, I mean, I need to learn these things because I need to understand, like, what is the word? Binary exploitation challenges. And a lot of them have to do with what the pointer is doing. Okay, so let's see if anybody's on InfoSec streams. Cyber Doctor's on. Okay. So Cyber Doctor works for a cybersecurity consultancy agency, I'm pretty sure. And he's been documenting his journey on cybersecurity over on Twitch. Atvow says, you're non-binary. Are we talking about computer stuff? Okay, let's start the raid. Your Cyber Doctor. Okay, when you arrive at the Cyber Doctor's channel, if you give this message right here, OSFrog, Hip Hop Hack, OSFrog, I would really appreciate it. Thank you very much. Alright, we'll be back tomorrow. Hope to see you there. And have a good one. HackerFrogs out in 5, 4, 3, 2, 1. See you next time.